Good morning, students. In our last video, we studied about some tests to check the convergence and divergence of an infinite series. In last video, we studied about Cauchy's root test. So today we are going to study about D-Alembert's ratio test. The heading is D-Alembert's ratio test. So again the statement, if summation un is a series of positive terms and if limit n tends to infinity un plus 1 by un. So you have un, so you have to find un plus 1. So un plus 1 divided by un equals L. Again same procedure as you already followed in your last video. So and you have to solve this ratio and you have to substitute n equals infinity. Again if you got some quantity, some finite quantity in RHS, and if that value is less than 1, then the series is said to be convergent, and it is divergent if this value is greater than 1, and test fails if it is less equal to 1. So it is nothing but ratio. Ratio means you observe un is nothing but summation of first 10 terms. So what you have to find? You have to find next term. What is un plus 1, and you have to divide with un. So it is of the form ratio. Ratio means numerator by denominator. So once you got this term, and you have to substitute, and you have to solve this limit n tends to infinity. Okay, we'll solve one problem. You'll get to know. Okay, test for convergence. So it is 1 square by 2, 2 square by 2 square, 3 square by 2 cube, 4 square by 2 power 4. It will go on. The series will go on like this. So don't cancel this. So don't cancel 2 square. Don't solve this. So what you have to do, so in order to write this un, you have to observe. You have to write the generalization. How this is going? 1 square, 2 square, 3 square, 4 square. It will go on. It is of the form n square. So you have to generalize. So it is n square. Denominator is 2 power 0. Sorry, 2 power 1, 2 power 2, 2 power 3, 2 power 4. So it is nothing but 2 power n. So once you got un, what you have to find? What is un plus 1? Un plus 1 is just n is replaced by n plus 1. N is replaced by n plus 1 whole square divided by 2 times n plus 1. And what is un? Un is already this. So what you have to do? So you have to find ratio un plus 1 divided by un. What is un plus 1? N plus 1 whole square divided by 2 power n plus 1 can be written as 2 power n into 2. 2 power n plus 1 can be written as 2 power n into 2 divided by un means again it will become reciprocal, which is nothing but 2 power n divided by n square. So again so in order to solve these problems, you have to always take first term as common, or you can take n as common. So taking n as common, so this 2 also will come here. So n square will come outside. It is 1 plus 1 by n whole power n square. Again 2 power n into 2, and denominator is n square. So this n square and this n square will get cancelled. When you substitute limit n tends to infinity un plus 1 by un, limit n tends to infinity. So this n square is already cancelled. Right, what is remaining? 1 plus 1 by n whole square divided by 2. When you substitute n tends to infinity, 1 by infinity, which is nothing but 0. 1 plus 0, which is nothing but 1. 1 by 2. 1 by 2, which is nothing but half, which is strictly less than 1. So the given series is said to be convergent. So what you have to do? So you have to observe and you have to write the generalization form or simplified form, and you form the ratio and apply the limit. So very simple. No need of that much difficulty is there. Okay, next problem. Test for convergence. 3 by 4 plus 1, 3 square divided by 4 square plus 1, 3 cube divided by 4 cube plus 1, 3 power 4 divided by 4 power 4 plus 1. It will go on. So again, what is un? So observe the pattern. You have to observe the pattern. 3 square, 3 cube, 3 power 4. So in general, what is the pattern in numerator? Which is nothing but 3 power n. What is the pattern in denominator? 4 power 1 plus 1, 4 power 2 plus 1, 4 power 3 plus 1, 4 power 4 plus 1. What is general? 4 power n plus 1. So what you have to do? You have to find the ratio un plus 1. It is nothing but n is replaced by n plus 1. 3 times 3 power n plus 1 divided by 4 power n plus 1 plus 1. And after this, what you have to do? Find un plus 1 divided by un. Limit n tends to infinity. What is un plus 1? 3 power n plus 1 divided by 4 power n plus 1 into 1 into, again divided by un means it will become reciprocal. 4 power n plus 1 divided by 3 power n. Now see here very carefully. 3 power n plus 1 can be written as 3 power n into 3. That is law of indices. So 3 power n plus 1 can be written as 3 power n into 3. Again, I am taking 4 power n as common from this. So the first term is 1 plus Here 4 power n is not there, so it will divide. So it is nothing but 1 by 4 power n divided by, again taking first term as common. So 4 power n plus 1 taking as common. So 1 will remain here, plus 4 power n plus 1 is not here. If the term is not here, you have to write it that in denominator, and 3 power n as it is. 3 power n will get cancelled. 4 power n will get cancelled, and remaining is 4 power 1 will remain because it is of the form 4 power n plus 1. So 4 power n into 4, only 4 power n will get cancelled, and remaining is 4. When you substitute n equals infinity, so this will become 0 and this will become 0, which is nothing but 3 by 4. 1 plus 0 divided by 1 plus 0, which is nothing but 3 by 4. So again this value is strictly less than 1. So this is convergent. Now I will explain how this is 0. So when you observe this, it is of the form 1 by 4n. 1 by 4n. Again this can be written as 1 by 4 whole power n. So again it is nothing but geometric series, because when you substitute n equals 1, it is 1 by 4. When you substitute n equals 2, which is nothing but 1 by 4 square. When you substitute n equals 3, it is 1 by 4 cube. It will go on. Again it is geometric series. And what is the common ratio? Common ratio is 1 by 4. As you already studied, if your common ratio is less than 1, then the series is said to be convergent. So when the series is convergent, so when you are going to substitute n equals infinity, since r is less than 1, so since r is less than 1, therefore r power n tends to 0 as n tends to infinity. Since r equals 1 by 4, which is less than 1, so this term, so this 1 by 4n will tends to 0 as n tends to infinity. So it is nothing but 1 plus 0. Again similarly, same way, 1 by 4 power n plus 1. So what do you have? 1 by 4 power n plus 1. This can be written as 1 by 4 power n into 1 by 4. Keep 1 by 4 as it is outside. Again 1 by 4 power n. Again it is of the geometric series. And what is the common ratio? Common ratio is 1 by 4. Again common ratio is 1 by 4. Again which is strictly less than 1. So r power n tends to 0 as n tends to infinity. So this term will tends to 0. 0 into 1 by 4, which is nothing but again 0. So again observe it is 1 plus 0. So altogether the value is 3 by 4, which is strictly less than 1. Therefore the given series is convergent. Okay. One more problem we will see. Examine the convergence of the series n factorial whole square divided by 2n factorial into x power n, where x is greater than 0. Again consider this as un. So what is un? The same thing, n factorial whole square divided by 2n factorial into x power n. So what is un plus 1? Un plus 1 means just replace n by n plus 1. So n factorial is replaced by n plus 1 factorial whole square divided by 2 times n plus 1, which is nothing but 2 times n plus 1, which is nothing but 2n plus 2. Just multiplication. 2 times n plus 1, it is nothing but 2n plus 2 factorial into x power n plus 1. Again next un plus 1 by un. So already un plus 1 you already have, n plus 1 whole factor whole square into x power n plus 1 divided by 2n plus 2 factorial into divided by un. So reciprocal it will become 2n factorial divided by n factorial whole square into x power n. So now listen here. So you have n plus 1 factorial. So what is n plus 1 factorial? N plus 1 into n factorial. So what is 10 factorial? 10 into 9 factorial. Correct? 10 factorial is 10 into 9 factorial. So you have n plus 1 factorial. So n plus 1 factorial can be written as n plus 1 into n factorial. So observe, n plus 1 factorial can be written as n plus 1 into n factorial. So obvious square is common. So n plus 1 whole square into n factorial whole square. Again x power n plus 1 can be written as x power n into x, and 2n factorial as it is. Again 2n plus 2 factorial can be written as 2n plus 2 into 2n plus 1 into 2n factorial. Again n factorial whole square and x power n as it is. Why I am writing like this? Because I have to cancel. So if I reduce this to this, easily the terms will get cancelled. So these are things you will get while solving more and more problems. So your main intention is to cancel the terms. So I am splitting like this. So n plus 1 factorial can be written as n plus 1 into n factorial. Similarly 2n plus 2 factorial can be written as 2n plus 2, 2n plus 1 into 2n factorial. And this square is as it is. So whatever this square is there, so this is common. So cancel the terms which will get cancelled. N factorial whole square, n factorial whole will get cancelled. 2n factorial will get cancelled. X power n will get cancelled. So what is ultimately remaining? N plus 1 whole square into x divided by 2n plus 2 into 2n plus 1. So what is the next step? Limit n tends to infinity, ratio, limit n tends to infinity. Again taking n as common. So this 2 also will come outside. So n square. So because if you take n as common, So 1 plus 1 by n whole 2 is also there. So it is n square into 1 plus 1 by n whole square into x divided by, again taking 2n from here as common. What is there? So taking 2n as common, it is nothing but 1 plus 1 by n. Again taking 2n common from here, again it is 1 plus 1 by 2n. Again when you substitute limit n tends to infinity, 1 by infinity is 0, which is nothing but 1 plus 0 whole square times x. Again n square, this n and this n square, and n square will common, and what is 2 2s are 2 2s are 4, and it is again 1 plus 1 by infinity, which is nothing but 0. Again it is 1 plus 1 by infinity, which is nothing but 0. So what is remaining? Remaining is x by 4. So hence by ratio test, series convergent if x by 4 is less than 1, and series is divergent if x by 4 is greater than 1, and test fails if x by 4 equals 1. So what is the meaning of this? X by 4 is less than 1, which is nothing but x is less than 4, and x by 4 is greater than 1, which is nothing but x is greater than 4. Hence by ratio test, x is less than 4, it is convergent, x is greater than 4, it is divergent, and test fails when x equals 4. Okay, thank you.